Hi Steve, welcome to my laboratory. This is where we make the tests of our reactors and of the modules that we will go to compound the 1 megawatt plant that we are manufacturing and that will be started in October in Greece. Let's start from the very beginning. We have here the plug that is taking power from the grid. You can say that we are drawing 3.4 amperes. 3.4 amperes is with a voltage of 220 volts, which is the normal voltage in Italy. So we are taking 3.4 times 220 is 748 watt-hour per hour. This is the energy that we are taking out. Later we will see how much is the energy that we are producing with the ECAT. Now you will see the ECAT. The ECATs are these. These are the ECATs. At the moment we are making a test with one ECAT, which is this one. This is the thermocouple that measures the temperature in the chimney of the reactor. The reactor is this, in this area. This is the insulation, the black one. And this is the chimney. And from the chimney exits the steam, which through this black hose goes to the sink. And here is the sink, and the steam goes through there. And we also have another thermocouple, which is this one. This thermocouple measures the temperature of the water that goes inside the reactor. This is a pump that pumps the water from the reservoir to the reactor. So you can see this pipe pumps, through this pipe, the pump pumps the water from the reservoir and sends the water through this blue hose to the inlet of the ECAT, which is this. Here we have a double wall jacket. Between the two walls we have a flow of water. The water cools down the reactor and steams up. The energy will be calculated considering the amount of water that we consume every hour, which we obtain by measuring the weight of the water that we consume, and the delta T, the difference of temperature between the two thermocouples. In this, all the data of the two thermocouples, you can see from these wires, flow through this data collector, and this data collector sends the data to the computer. In fact, if we go to see the monitor of this computer, we will see that we have in the first column C1 is the room temperature. Today is a very hot day. We have 31.8 Celsius degrees in the room. Besides, here we have in C2 the temperature of the water at the inlet of the reactor, which is the water in the reservoir, which is in this moment 26.5 Celsius degrees, while at the output we are measuring 100.1 Celsius degrees, because it is steam. We have room pressure, so as everybody knows, at 100 C degrees the water boils and becomes steam. These are the curves from which you can see all this. The blue bottom line is the water inlet, the red line is the room temperature and the yellow line is the temperature of the steam. Now, we see this is the control panel. This is the control panel. Here happen all the regulations of the system. All what happens inside the reactor is regulated through this. Also temperatures, pressures, etc., etc. And here...
You can open the cover?
Oh, sure. Inside the cover, now I can open the cover just to let you see that here is not exotic. You can just see that here inside are no batteries or some exotic Flash Gordon systems or some stupidity like that. This is just electronic stuff. Well, and here you see another very important thing, which is the measurements of the gamma rays. This is the measurement of the gamma rays. Now we are measuring 0.15 microsievert per hour in the environment outside the reactor. This is a standard, let me look at this. This is a standard gauge to measure the gamma scout. This is a gamma scout registered mark. So be it. I am not an expert of these systems, but in this moment he is giving to us this data, 0.13 microsievert per hour, which means that we are pretty safe because, of course, the reactor is shielded and the gamma rays are thermalized. The low energy gamma rays are, which we produce are thermalized inside the reactor, and it's for this reason that we have an energy production. Now, to have a very rapid calculation of the energies that
wait. Before calculations, we missed the hydrogen.
Oh yes,
you are talking about hydrogen and then the outflow.
At this point, I have also to show you the hydrogen system. This is the hydrogen tank, and the hydrogen before we start the production, this cap is screwed to this point. Now we have a security cap. We take off this cap, we screw this one, and through this hose we discharge the hydrogen inside the reactor. And I can say that with 1 gram of hydrogen we have 24 hours of work. And so basically you can think we put this here as security and we screw this right here. After taking off this green cap, we put at this place this silver cap and open here and here, and we will have the pressure and we have the hydrogen inside the reactor at the pressure that we want. Then we close everything. The hydrogen is charged in batch. And then for 24 hours it is all set. Now, if
the heat out, which
I just now I can explain better the system of water distribution. As you see, water arrives from here, is pumped by the peristaltic pump through this valve, goes inside the double jacket. Here inside we have a double jacket. Between the two jackets there is the cooling water, which is the water that we steam up to collect the energy. And the water comes here. This is the chimney. At this point the water is evaporated because here we are above the 99.9 C degrees, which is the upper limit of liquid status for the water. And here we have pressure, room pressure. This is very important to specify because the boiling point is also a function of the pressure. And this is the thermocouple that measures the temperature of the water in the chimney. Then the steam flows through this pipe. This, of course, is at about 100 Celsius degrees, so you cannot take your hand above. And this goes to the sink of the sink of the steam that is right there. Some steam is going out because is going out of not many parts, because much of what goes out is, yes, we have some condensation, but very small condensation, because this is very short, and so the maximum part is steam that goes out.
We can see the steam?
Yeah, sure. Just a moment. Just a moment that, because okay.
I guess we can, I don't know if it's...
You ready?
Yes.
Put it.
Ah.
Got it?
So, you see,
Explain what we're seeing.
Steam. This is steam. And of course, it is not that much visible because it is very hot. Being very hot, it has less density, and so it is not very. But you can see the steam. Yes, exactly. We have washed it also, because before
I have my shirt.
on white you have steam is white. So you have white on white, you could not see very well. So with black you might see, but it is still not so much visible because it's very hot. Steam, you can see well steam when it is very low, at the low temperatures, like fog. But when it is very hot, it is very dispersed.
Okay. So what flow rate is going now?
In this moment we are making 7 kilograms of water per hour. 7 kilograms, which we know perfectly because we weighed the water that we put inside. Every time that we recharge the reservoir, we weigh the water, and so we know exactly which is the weight of the water that we are passing through the reactor in 1 hour.
At what temperature can this...
100.1.
But
Put your hand on.
It's hot. This is plastic?
No, this is a special rubber. This is a special rubber for high temperature. This is a rubber which resists up to 180 degrees Celsius.
Okay. So what else? So results?
Now we can make the calculations, but we can make the calculations in the table with pen if you want.